This is the solution for a question covering the sublearning outcome multi-component system from Mechanics 1. In this question, we are going to replace the force system acting on the post with a resultant force and a couple moments at point O. We will first draw a coordinate system with positive force acting upward and to the right, and a positive moment rotating counterclockwise. We have to resolve the 300 pounds and 150 pounds into their x and y components. We will draw the components in dotted line. The x component for 300 pounds should be 300 pounds multiplied by cos 30 degree, and the y component should be 300 pounds multiplied by sine 30 degree. Now, we will look at the force of 150 pounds. The question has told us it is a 3-4-5 triangle. Therefore, we get the x components of this force should be 150 multiplied by 4/5, and the y component should be 150 multiplied by 3/5. We have found the components of the forces, and now we can find the sum of force in both x and y directions. The total sum of force in x direction equals positive 300 pounds multiplied by cosine 30 degrees, positive, because the force is acting to the right, plus positive 200 pounds, positive, because the force is acting to the right, plus negative 150 pounds multiplied by 4/5, negative, because the force is acting towards the left. After the calculation, we get the sum of force in x direction equals 339.81 pounds. We will next calculate the sum of force in the y direction. Positive 300 pounds multiplied by sine 30 degrees, positive, because the force is acting in the upward direction, plus positive 150 pounds multiplied by 3/5, positive, because the force is acting in the upward direction. We get the sum of force in the y direction equals 240 pounds. We have found the total sum of force in both x and y directions. We can now use the Pythagorean theorem to find the magnitude of the resultant force, which we will write it as Fr, which equals the square root of 339.81 squared plus 240 squared. We get the resultant force equals to 416.02 pounds. Next, we have to find the angle of the resultant force using trigonometry. The angle equals the inverse tan with opposite over adjacent, which equals the inverse tan with 230 over 339.81. So we get the angle equals 35.23 degrees. Then, we need to find the equivalent resultant couple moment. The total sum of moments at point O equals positive 150 pounds multiplied by 4/5, multiplied by the perpendicular distance from point O, which is 4 feet. Positive, because it is causing a counterclockwise moment about point O, plus negative 200 pounds multiplied by 2 feet, negative, because it is causing a clockwise moment about point O, plus negative 300 pounds multiplied by cosine 30 degree multiplied by 6 feet, negative, because it is causing a clockwise moment about point O. We get the total sum of moments about point O equals negative 1,478.85 pounds-feet. We will draw the moments rotating in the clockwise direction on the diagram because the answer we got is negative. Notice that we did not add the y components. This is because the force in y direction did not contribute with the moments at point O, as the line of these forces passed through point O. So the normal distance between the y components and point O is 0. We get the equivalent resultant force is 416.02 pounds with an angle of 35.23 degrees, and an equivalent resultant couple moment of 1,478.85 pound-feet rotating in a clockwise moment, both acting at point O in order to replace the force system acting on the post.